With Kroger brand products from Baker's, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Baker's, fresh for everyone.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you so much for joining us on this, the podcast affectionately known as Space Nuts, the final one ever this year. My name's Andrew Dunkley, your host, and with me as always is Professor Fred Watson, Astronomer-at-Large. Hello, Fred.
Hi, Andrew. Good that you're hosting it, because I couldn't do that.
I couldn't do what you do, so it's lucky the way things worked out.
Isn't it astonishing? We should get together sometime.
We should. Actually, a lot of people write to me and ask when we're going to do a face-to-face or when we're going to maybe do a vodcast or a live cast or something like that. We have talked about it. It's just really hard because we are both particularly busy and not in the same city, not even remotely close to one another. So it's a little bit difficult.
Once in a while, we do get together and we'll make it happen.
We will do it.
Maybe we should set that as a target for 2020, Andrew.
That'd be lovely.
Some point to do a vodcast or something like that.
I think we should do it for the 2028 eclipse.
Oh, we should. That's right. By which time I'll be 193.
Yes.
You'll be 27.
Something like that.
Yeah.
Yes. Now, today, Fred, we've got a couple of exciting stories to finish off the year. NASA has announced the landing site for the Mars 2020 mission. That's the whole story, so we don't have to do that one. And they've announced the names of a bunch of exoplanets, and several countries got to name these, including Australia. We'll look at those. And we've got some questions. One in particular I'm keen on, Fred, because this came from 13-year-old Michaela in Dubbo, which is where I am. She asked her science teacher and he went, "What?" No, he didn't. But then she asked her dad, and her dad told her to ask me. So now I'm asking you. So it's about gas giants. And we're also going to tackle Liam's question about what might be the cause of gravity. So let's get into it. NASA has announced the landing site for the Mars 2020 mission. Before we talk about the landing site, maybe we should talk about the mission proper.
Yeah, so Mars 2020 is indeed a very interesting mission. It's the next NASA step in exploration of the red planet, and what it's doing. So. Recall that Curiosity, which is the rover still active on the surface of Mars, that was sent there in 2012 to establish whether Mars was ever habitable by looking at the geology. And basically, it answered that with a yes within about a month of being there. But it's still going strong and exploring the landscape of a place called Gale Crater, which has a mountain in it called Mount Sharp, and Mount Sharp's got lots of outcrops that are very suitable for geological exploration, which is what Curiosity is doing, and it's doing a fantastic job. So the next step is to look not just for signs of habitability, but to look for signs of ancient microbial life and perhaps even current microbial life on Mars. So this is specifically a mission looking for life, looking for looking for living organisms or evidence of past living organisms.
Mission we've all been waiting for, really. It's not the first time we've done it. Wasn't it one of the Vikings that went up there looking for life, and they just scooped up a pile of dirt and went, "No, nothing here."
Yeah, actually, they didn't. They said, "Well, that's interesting," and then everybody else said, "No, it's got to be something else." So there's still controversy about the Viking samples.
Yes, that's right. I remember we talked about that.
Yeah, but one of the other things that that Mars 2020 will do is to collect Royal and Sock samples. Soil.
You can get them at Buckingham Palace.
You can, yeah. The used sock department of Buckingham Palace is well known for.
I think they sell them in the gift shop.
Indeed, that's right. Unwashed. No.
Oh, no, they'd sell for more.
Yeah, they probably would. Soil and rock samples. They'll collect soil and rock samples and store them actually on the surface. So there must be, Mars 2020 has probably got this box that they can put these rock and soil samples in and leave them there for a possible future mission that will retrieve the samples and bring them back to Earth. So in a sense, what Mars 2020 is doing, it's kind of the first half of a mission to find really interesting samples that you'd like to analyze in the laboratory, but it won't attempt to bring them back. But both NASA and ESA, the European Space Agency, they are looking at the possibility of a future mission to go and collect them and then bring them back to Earth. So it's sort of, it's very nicely as the JPL, Jet Propulsion Laboratory, who are responsible for this stuff, as they put it, that this landing site actually sets the stage for the next 10 years of Mars exploration, which I think is very exciting.
And it's so human. Let's pick up some rocks, put them in a box, and we'll spend billions of dollars and go and get them later.
Well, that's right. It's not that many billions of dollars.
I know it's not. I just couldn't help myself.
Yeah. You've heard me going on about that before, so I won't labour the point. It's relatively, considering what we do with this kind of thing, it's really pretty economical. Anyway, to cut to the chase, so the landing site that has been chosen, and I hope I'm pronouncing this correctly. I think it's Jezero Crater is the way it's pronounced. Jezero. I beg your pardon, Jezero.
No, you were right the first time.
Jezero Crater, and apparently there's really interesting terrain there. I've seen imagery of this place. The suggestion is that the landforms there go back 3.6 billion years, and that's kind of the time when we think that Mars was warm and wet, and of course the time when you would expect to find any evidence of past microbial life there. It's actually it's the western edge of a feature which is a well-known feature actually in Mars geography, which is called Isidis Planitia, which is a big impact basin, and it's basically just sits almost exactly on the Mars equator. It's slightly north of Mars's equator. It's not actually that far, Andrew, from Gale Crater, where Curiosity is. But, by not that far, I mean a quarter of the circumference of Mars. So it's
all relative.
It's all relative, yeah. It's not anywhere. So they're certainly not within reach of one another in any sense. They are basically in independent places on the Martian surface. But this crater, though, has some. Basically, it's got a delta in it from an ancient river flow.
Is that why they chose it?
Exactly, yeah. So it's a 45-kilometer wide crater, or 28 miles, and this ancient river delta is sort of inside the crater, and it's thought that would be a place which could have collected and preserved ancient organic molecules and other potential signs of microbial life. I'm reading from the JPL press release at the moment, from the water that flowed into that crater through this delta and brought sediment with it. So if life is there, that this is a great place to find it. The press release goes on to say Jezero Crater's ancient lake delta system offers many promising sampling targets of at least 5 kinds of rock, including clays and carbonates that have high potential to preserve signatures of past life. Lovely stuff. I think it's really a great target. I had a look at some imagery of the region, and it's the geography there is so interesting with this crater and this delta system. The other comment that they make in the press release is the geologic diversity that makes Jezero so appealing to Mars 2020 scientists also makes it a challenge for the team's entry, descent, and landing engineers. Along with the massive nearby river delta and small crater impacts, the site contains numerous boulders and rocks to the east, cliffs to the west, and depressions filled with aeolian bed forms. That's basically dunes, wind-derived ripples, which you can actually see on some of the imagery. Wind-derived ripples in sand that could trap a rover. These are these aeolian bed forms in several locations. So a challenge as well as a desirable site to visit. And I think, as I understand it, I haven't really read the details of this, but there's a new technique for landing the rover, which
I was just looking at that. So they've got a series of landing points that they are going to consider, but they've also got a bailout point, as I understand it. So they've got a contingency built in just in case, which is wonderful. I'm glad the technology exists so that they can say, okay, we can't do that, let's go over there, and the mission can go on.
That's right. So they do that in real time, of course, because if you've got a rover coming down on a parachute in the last stages of re-entry, last stages of atmospheric entry, you want to try and steer it to a place free of boulders, exactly like Neil Armstrong did with Apollo, with the lunar module, where they were originally going to land was totally unsuitable. And so the same sort of technique is being applied here with Mars 2020. What the rover will do, I mean, effectively the capsule in which it's contained as it comes down on its parachute, they'll take photographs take images of the landscape beneath them as it comes down, and then that will be compared with the data taken from orbit. And if it shows signs of not being a desirable place, they can actually divert the spacecraft to a better landing site. So that's a really new and unusual feature of this landing. So I think that's really fantastic.
Yes, indeed. And they're talking about a July launch, which will see the rover hit the surface. Well, we better not use the word hit. Land delicately on the surface of Mars when? A few months later?
Yeah, it's typically 6 month time. So,
end of the year.
Yeah, it'll be at the end of next year. That's right.
And how much longer after that are we going to get data back to say, yes, we've found Martians?
Probably the day after, if it's anything like Curiosity was.
Yeah.
Curiosity was very quick off the mark with analysing the rocks around it. No, the day after is, of course, an exaggeration. But I think the signs are that maybe early in 2021 we might know whether Mars was ever inhabited by living organisms, even though there's always controversy with these tests. And, the last thing you want, as I think we talked about a couple of weeks ago, you can't just rely on what things look like, which is the morphology. That's the term we use for the shape of things. You cannot rely on the morphology because it can lead you astray, as it did in the case of that Martian meteorite. ALH, can't remember its number, very famous Antarctic meteorite that was thought to have microbial life in it from Mars. And these features that are seen in the rock are now pretty well universally accepted as being chemical in origin rather than biological. So you've got to do more tests than just, it looks like a microbe, therefore it is a microbe.
Yeah. Like that place we were talking about in Ethiopia. Yeah, exactly. I'm looking at a photo of the Mars 2020 rover. It's pretty cool. It's a bit of a gangly looking thing, got long legs.
Yeah. Has it got, my criterion for things looking cool is whether it's got automatically folding wing mirrors. Does it have that?
I don't think so.
No.
Well, it sucks.
They might not need that.
Yeah, that's become a thing. Mine automatically fold when I bump them.
Oh, right, okay.
But, it's not because they've got any electric motors in them. I just hit them pretty hard.
Hard and they fold up.
Yeah, only because my wife parks too close to me in the garage. That's the problem.
Right, I'm not going there, Andrew, so let's move on to the next story.
Or I've put on too much weight and can't get between the cars. That might be it too. But yes, all eyes on Mars 2020, and by this time next year, we may have something to tell you. I don't know what that will be. Or we found life, or we just found dirt. Could be one or the other, or both. You're listening to Space Nuts, episode 184. My name's Andrew Dunkley, and with me, Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, just want to shout out to our YouTube followers who number 777. We're only 223 away from the magic 1,000, which I'm sure we'll have by tomorrow. But that is fantastic. So thank you so much. If you're a YouTuber or you play a tuber and would like to listen to us on YouTube, please log into youtube.com/c/Space Nuts and subscribe to the Space Nuts YouTube channel. All our segments are on there from the very beginning right through to, well, now and beyond. So thank you for supporting us on YouTube. Greatly appreciated. Now, Fred, to our next topic of discussion, and this is one we sort of added late to the list because it sort of only came up today in the news, and that's the naming of exoplanets. Exoplanets being planets outside our own solar system orbiting other stars. Of course, they need names, and several countries have been given that honour, including Australia. So what did they come up with?
Oh, some great names.
Fred, Andrew, Mandu.
Excuse me. Sorry, I lost my voice there. I was so staggered by the number of names. Yeah, Fred and Andrew, they'd be good names, but actually don't figure in the list.
Funny that.
Let me introduce this by reading a statement from the chair of the Name Exo World Steering Committee. So this was a project of the International Astronomical Union, which is the governing body of astronomy. They're the body who actually are responsible for naming celestial objects. They are the group that actually dictates how objects are named. In fact, all working astronomers are members of the IAU, and I am too. I think I became a member in the 1970s. It seems like a long time ago now.
Whether you want to be or not.
I'm very honoured to be a member.
Just stir in the pot, Fred.
Well, sometimes we're called the Uber nerds because we're not just the nerds, we're the Uber nerds. But all astronomers, as I said, are in the IAU. So the chair of this committee, a gentleman by the name of Eric, I'm not sure whether I'm pronouncing his name correctly, Mamacek or Mamayek, not sure. I would guess Mamacek. He's got a little statement here which really absolutely encapsulates what this is all about. So I'm going to read it.
Sure.
Astronomical observations over the past generation, and it's not that long actually, that generation, have now discovered over 4,000 planets orbiting other stars, called exoplanets. The number of discoveries continues to double about every 2.5 years. And that's an astonishing statistic, but yeah, quite right. Revealing remarkable new planet populations and putting our own Earth and solar system in perspective. Statistically, most of the stars in the sky are likely to be orbited by their own planets. They are everywhere. While astronomers catalogue their new discoveries using telephone number-like designations, there has been growing interest among astronomers and the public alike in also assigning proper names, as is done for solar system bodies. And so that project, the IAU 100, I forgot to mention IAU is 100 years old this year, and we've been celebrating that in fact, we made a video representing Australian astronomy, which you can also find online.
IAU really quick to that video.
Have you watched it?
No, I'm just plucking another bad joke out of the sky.
Yeah. Sometime you must explain your jokes to me, Andrew.
Well, there wasn't much to tell. No, carry on.
So the Name Exo World's global project was basically, it's all about celebrating the 100th anniversary of the IAU. Basically, it's a cultural thing. It's all about involving people, almost like citizen science, but actually doing something useful, naming all these exoplanets. So there were 100 exoplanets selected, actually more than 100. Actually, another of the project managers for Name Exoworlds said the IAU 100 Name Exoworlds campaign provided the public with the exciting opportunity to help with the naming of over 100 new worlds and their stars, which is nice too, and to help the IAU establish a thoughtful naming theme for naming future discoveries in those systems. So yeah, there's a lot. You can find it all on the web. But a lot of these names that have been chosen are mythological and part of the culture of the various countries involved, of which there were 112. We had a national campaign here in Australia. We were one of the 112 countries involved. 780,000 people participated, nearly the number of people who listen to Space Nuts, Andrew. So, yeah, a lot of people were involved, and they were, they were distributed around the world. 24 of those countries were in the Americas and the Caribbean, 38 in Europe, 18 in Africa, 28 in Asia, and 4 in Oceania, including, of course, Australia. The other 3 were the Cook Islands, New Zealand, and the Pitcairn Islands. So Australia has been responsible for naming one of these worlds and its parent star. And let me tell you what it is. The star is called Bubup, or Bubup, and it's a Boonwurrung name. Boonwurrung is a language used by the one of the nations of Victoria, the Kulin Nation in Victoria. So this is an Aboriginal nation, the Boonwurrung language, one of the 200 or so different languages that we have in the Aboriginal culture.
For those who may not be aware, before white man settled in Australia, the Aboriginal people lived in a multitude of nations, many, many nations right across the continent, and they had multiple languages and multiple cultures and customs. It's something that's not really thought about a lot, and it's sad that some of that's died and gone forever. But there's work to preserve a lot of that as well, which is great. But it's good. What's it called?
Yeah, Bubup. That's the name of the parent star. And it's the Boonwurrung word for child.
Nice.
The planet is called Yan Yan, and Yan Yan is the Boonwurrung word for boy. So it's a child and a boy. They're quite nice names. Actually, the formal name of the star is HD 38283.
Oh, that's better.
Yeah. I think the new names actually kind of eclipse that rather.
I totally agree with you. Yeah. Have we got any names from other countries that have popped up? I see the Malaysian one is Masamam. No, I'm kidding. That's a form of food.
Yes, it is indeed. Look, they actually, that's right. It's in fact, the Malaysian one is an exoplanet which is called HD 20868. Its planet, the star is called Intan, and the planet is called Baiduri, and I don't know what they mean. The names of gemstones in Malay language. Oh,
wow!
So that's quite nice. There are Irish names which are actually from mythological dogs, Bran and I think it's Turin. And from Irish legend, the birth of Bran, I do remember hearing about that when I lived in the UK. But Bran is the name of the planet. Turin is the name of the star, and they're actually very neatly in the constellation of Canis Vetanici, which you will know is the hunting dogs, a Northern Hemisphere constellation.
Very clever. Very clever the way they've come up with that. Yeah.
So, I think that's a great story, and I think congratulations to everybody who put in their bits for these names, and well done. And I think we will see this kind of exercise happening more commonly in the future as time goes on.
I would hope so, because it makes exploration of the universe a global cooperative effort, which I think is very important, and right down to naming exoplanets. If people want to look up what the names of the exoplanets are, they can do that by visiting the IAU website, iau.org. and they have a little news tab there. You can look up the information and find out what your home country got to name their respective exoplanets. And, of course, you get to go there as a part of the deal, eventually.
What, to the country or the exoplanet?
The exoplanet, of course. No doubt about that.
Yeah.
All right. No, it's fantastic. And, some of the names are quite magical. You're listening to the Space Nuts podcast with Andrew Dunkley and Fred Watson.
0G, and I feel fine.
Space Nuts.
Now, Fred, I want to send out a big thank you to our patrons. We've had some more sign on in the last week or so. One in particular that's gone above and beyond. We give our patrons names, so depending on how much they decide we're worth, you can be a supporter, an ensign, a lieutenant. I think the latest person to sign up should probably be given 5-star general status. So thank you so much for your generosity. And if you'd like to be a patron and support this podcast through, a handful of dollars a month, preferably hundreds. No, I'm kidding. Patreon.com/spacenuts. It's optional. You don't have to do it. But as a patron, you are getting bonus material through our Patreon account, and we will be adding more and more material to that. And you get bonus questions answered through Patreon. So it's patreon.com/spacenuts. Go and have a look. And if that's something you want to do, that's totally up to you. And we certainly do appreciate the support we get from our patrons and everybody for that matter, including those in the Space Nuts Facebook group, which is ever growing. We get more and more people joining the group every day, Fred, and chatting to each other and asking questions of each other. Sometimes they'll drop my name in and say, you really need to get this one to Fred, which I do. And so that is part of the deal. But, it's a great little community that's been set up through Facebook. So if you're not a member of the Space Nuts Facebook group yet, look it up and join. Now, Fred, to our questions, which we always do to finish off the show. And this is a question from Michaela, 13 years old. Michaela's from Dubbo, which is where I am. She asked her science teacher this question. He didn't quite know how to tackle it, so she asked her dad. And her dad asked me, and now I'm asking you. She basically wants to know if Jupiter was to change from a gas giant into a solid, would it still have an atmosphere? Now, the question is, can gas giants turn into solid objects?
No. Not in the normal run-of-the-mill thing. So Jupiter's never going to change from a gas giant to a solid object. But you can envisage a situation in which it might, but it's sort of prohibited by the physics of the universe as they stand. But if Jupiter was cooled down to not very much above absolute zero, excuse me, then the gases that make up Jupiter's atmosphere, sorry, Andrew, got a frog in my throat there, thinking about
year, Fred.
About
the
Jupiter
voice is ready to give up.
Jupiter turning from a gas giant into something else. What would cause that? A temperature way beyond the temperature of space, which is 2.7 degrees above absolute zero. And at that temperature, all of the gases in Jupiter's atmosphere would freeze. They would be solid, including what Jupiter's the most prolific gas in Jupiter is actually hydrogen, which is the lightest of all the elements, and that freezes at a very low temperature. But there's no, if you freeze Jupiter to make it solid, there's no other gas that can remain as an atmosphere. So the answer is no. You can't have an atmosphere and a solid Jupiter as well.
Okay. That's fairly simple to answer then. So it's, I mean, there was some suggestion that if it could, it would take a long time, like trillions of years. So,
yeah,
the circumstances would have to be rather extraordinary, I imagine.
If you think to the long-term future of the universe, when all the stars have finished shining, all turned into basically things that don't radiate energy anymore. The universe slowly cools over periods of probably hundreds of billions of years, and eventually you would have a very cold and pretty boring universe with not much happening. And that might be a scenario in which gas giants could freeze solid, and there would be no atmosphere there.
And we wouldn't be around to deal with the situation anyway, or Space Nuts would still be going to report.
I'm sure it would still be echoing somewhere through the cosmos in the backwoods of Alpha Centauri or something like that.
Indeed. All right, there you are, Michaela. So it's probably beyond the realms of possibility, really. So thank you for your question, though. I really appreciate it.
It's a good question. That's
Now we turn to Liam Woodman, who is asking a question of gravity. Is anyone looking at the concept of gravity being a result of a form of pressure or similar caused by matter being a type of interference, contamination, if you like, which our universe is trying to squeeze out? The universe doesn't want matter. It wants to be pure, not in the a sentient being kind of way. Matter, regardless of how small, creates a hole in space-time, and therefore the more matter, the bigger the hole. Bigger holes have a greater pulling effect as matter is disturbing a greater area, and so more of the push from our universe is being directed at it. This means even a single atom, being the only thing in the universe, would feel the effect of the entire universe, and vice versa. When the fabric becomes so stretched it breaks, we get a black hole. So therein lies the question.
Well, the last bit is the bit I would take issue with. The preamble there is really, in some ways, it's just another way of expressing how we know gravity works. Because gravity is a property of the universe itself. It is a disturbance caused by matter, and it basically does the way we express gravity in relativistic terms is a change in shape. It's a distortion of space, but that manifests itself as a kind of pressure. That's what's holding us onto the ground. We wouldn't use those terms. We would use a force field really as the terminology, and that's what that distortion of space produces. It produces a force field which essentially is what sticks us onto the ground, and to regard it as a pressure caused by the universe trying to squeeze stuff out that it doesn't like. I think that's just putting it in a rather more human term, but it is the same phenomenon essentially as we describe in more scientific terms. I don't think what Liam suggests is that the universe is almost like an irritation. That matter is an irritation to the universe, and that's quite an interesting way of putting it. But the bottom line is that matter has this property that it changes the nature of space, and we see that as gravity. Now, the fabric being stretched to the limits and then breaking, getting a black hole, is a different way of putting what we understand black holes to be, which are points of infinite density. So this is a point where matter has reached an infinite density because even though its mass might vary, but the volume is always zero. It's because it's a single point, a singularity. And at that point, actually, our understanding of gravity really breaks down. This single point is a place where our present physics doesn't really hold up. And we find all sorts of contradictions, like, infinite density for a start is a contradiction. How can something have infinite density? Well, it does. That's a black hole, and we see them. We see the phenomenon in existence. I don't think it's to do with the fabric of space breaking. There is talk in some circles of something called the Big Rip, which is when the universe has expanded so much and we're now talking about hundreds of billions of years in the future, again, assuming that the current accelerated expansion continues. When it's expanded so much, there may be a point at which space itself cannot hold together and it just breaks down. But how the physics of that work is really, once again, conjecture. People have speculated it. It is, as I said, called the Big Rip. You probably find quite a lot written about it on the web, much of which will be from theoretical physicists, probably backing it up with some equations which none of us will understand. But it's possible that maybe things do tear. But that's different from our understanding of a black hole.
Liam also said this may also mean a black hole could potentially be caused by a single atom relative to how much matter is in said universe. I suppose no.
Well,
I
yeah,
mean, black holes are caused by much larger cataclysmic events, I guess.
They are indeed, but they're the collapse that produces a black hole. You've got something much, much bigger, whose mass is enough to overcome the forces that hold atoms apart and atomic nuclei apart, and you wind up with this collapse to an infinitesimal point. So the dimensions of a black hole are much, much smaller than the dimensions of an atom, but the mass that it contains is, larger than the mass of a star. In fact, of 10, 20 solar masses. So that is one of the many conundrums that surrounds black holes.
And if you want to read about atom-sized black holes, there's this great book called Parallax that's available for Christmas. No, I'm kidding. How's your book going too, by the way, Fred?
Yeah, pretty well. And there's a whole chapter on black holes. So if you really want to find out about black holes, I think the chapter is called The Eye of the Storm. That's in Cosmic Chronicles, which is out in Australasia. But if you are elsewhere in the world and want the English edition, that will be published next month by the Columbia University Press in America, and it will be called Exploding Stars and Invisible Planets. Thank you for the plug.
No worries. You can also buy a copy via the Space Nuts website, Bytes, bitez.com/Space Nuts. All Fred's books are there, and a couple of some other jokers' books are on there as well, and all our Space Nuts paraphernalia. If you want a T-shirt, you can buy a Space Nuts T-shirt. People have been buying them, Fred, taking photos of them and sending their photos back to us of them wearing their T-shirts, which I think is fantastic.
Yeah,
so, thank you for your question, Liam. Thank you, Michaela, and thank you, Fred. It's been a fabulous year. Boy, we've gone through so much stuff this year. It's mind-boggling. And the number of people who write to us and say that they just love the podcast because it gives them so much information they've never learnt so much is, I guess, what it's all about. And we are certainly planning to be back next year to keep it going. I don't think we'll change a thing. No one's come to us and said, can you change your format? I mean, really? That hasn't happened yet. Well, yeah, it has a lot of times, but we ignore you. But I want to thank our patrons for signing up and just sending a few dollars our way to keep it going. I want to thank all the people who listen. I want to thank Hugh in the control room, who puts everything together, gets it out there, does all the deals. He's a tireless worker, is Hugh. I used to work for Hugh for one of the radio networks that I worked for, and this was his plan when he left radio, and it's going so well. He should be very proud of himself. Our Facebook followers, our YouTubers, everybody, Fred. But without you, it would be nothing. So thank you so much, Fred. You are fantastic.
It's always my pleasure, Andrew, and we will keep it going next year. Meanwhile, I hope everybody has a fantastic festive season, great holidays, and I'm off to the Arctic to look at the Aurora Borealis.
Oh, so nice. That'll be lovely. We'll talk about that when you get back, and many other things, I'm sure. Lots to look forward to in 2020. Thank you, Fred, and thank Marnie, your partner in crime, for her support and ongoing what's the word I'm looking for? Toleration of us using her bandwidth, most importantly.
Yeah, that's right.
But, it's fantastic. Thank you again, and have a Merry Christmas, you and Marnie and Mandu and the Chooks, and we'll talk to you again in 2020.
Sounds great. You too, Andrew. Very best to you and yours, and we'll speak soon.
Thank you, Fred. Fred Watson, Astronomer-at-Large. And from me, Andrew Dunkley, have a wonderful festive season. Hope you get to spend time with family and friends, and we will look forward to talking to you again in the new year. From all of us at Space Nuts, Merry Christmas.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.
With Kroger brand products from Baker's, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Baker's, fresh for everyone.